Here is a recap lesson of our first lesson in Unit 4. So we'll start off with a warm-up. If you didn't grab it, grab one. And we'll take some notes on classifying triangles. And then there's some practice Khan Academies and a worksheet that goes into a little bit deeper of the concept. And then there's a short exit ticket. So grab a new table of contents and put today's date. I don't know if this is the right color because I haven't printed it off yet as I'm making this video. But our new Unit 4 is about triangles and special segments in triangles. So one of the old formulas you need for today is the distance formula. So pause the video and go through your notes and find the distance formula and write it down right there. Okay. Grab one of the warm-up sheets if you haven't, and there are 3 different shapes. You want to make sure you have a sheet that has an obtuse, an acute, and a right. So you basically have 3 different shapes in your group. If you don't remember, an obtuse looks like it's got a big old angle, acute, they're all less than 90, and a right has a 90-degree angle. And then we're going to grab a protractor and we're going to measure all these angles with our buddies. So each person should have one piece of paper in front of them that they can work on their own, and then you can rotate and help each other out. If you don't remember how to measure an angle, what you do is you put the protractor on the corner point, the little dot on the corner point, and then you kind of follow that line along and see where it touches. Now there's 2 numbers here that I'm hitting, the outer numbers and the inner numbers. Remember, this is an acute angle, so we want a number less than 90. Also, we start counting with 0, so I would use the outer numbers. So this is about 24 degrees. Yours is a little bit different. So measure all of your angles. Let's act like I measured everything. And I measured my 3 angles. This is just from an online program called GeoGebra. And then when you measure your sides, please measure them in centimeters, because we haven't been so good at measuring in inches because it's a different base, broken up. Okay. Oops. Okay. So here is just a summary of what I would have measured on paper. This is not the answers to the warm-up, but how do we put it in the little table right here? So the smallest angle, if I look at my 3 angles, my smallest angle is 24, and that's called angle C. My medium angle is 28 degrees, and that's angle A. And my largest angle is 128, that's angle B. You can check your measurements by making sure they all add up to 180 degrees. Okay, now for my sides, my smallest side is 9.8 centimeters, and it's between sides A and B, so I'm going to label it side AB. My medium side is 11.6, and it's between these angles BC, so I'm going to label it BC. And then my long side is 19.3, and it's between the angles A and C, so I'm going to call it side AC. So give yourself a minute to label or to fill it all in your table. Make sure you label your angles and your sides as you're filling them in. One thing I want you to notice is as we are filling this in, this is on the warm-up sheet, as we're filling it in, hopefully you realize that across from the smallest angle is which side, the smallest, the medium, or the large side. So find your smallest angle and jump through the triangle and figure out what that is and write it down. Okay. Now do the same thing for across the largest angle. So find your largest angle, jump through the triangle, and write it down. Hopefully you realize across the smallest angle when I jump through is my smallest side, right? They're both the smallest. And across from my largest angle, this 128, when I jump through the triangle, across from it is the largest side. So those are the answers. That's always going to work no matter what type of triangle you have. Now, if you have an isosceles triangle where 2 angles are the same and 2 sides are the same, I mean, you have 2 smallest sides, basically, or 2 largest sides. Okay, so back to my shape right here. I have it. Again, I jump through the triangle. That's my smallest side. Find my medium angle, jump through. That's my medium side. Find my large angle, jump through. That's my largest side. On Khan Academy, when we practice this, it's going to ask you to label your angles from either smallest to largest or largest to smallest. So it's not going to give you the angle measurements. You need to look at the side lengths. My smallest side is 3.5, so across from it, that's my smallest angle. My medium side is 3.8. Across from it is my medium angle, and my largest side is 3.9. Across from it is my largest angle. So that's how you would do that Khan Academy assignment. Okay, later on the page, triangle proofs. So there's two things we're going to talk about. Let's start off with triangle inequality theorem. This states that the sum of two smaller sides must be greater than the third. And this is the triangle inequality theorem formula. What it's saying is if I have three numbers, three side lengths, they don't always make a triangle. The two smaller sides have to add up to a number greater than the largest side. And I'll do a little demonstration in class. But basically, if they're less than it, it's going to make a straight line that doesn't quite connect. And if it's equal to it, it's going to make a straight line. So with our example right here, I can check it because I can check my two smaller sides, 9.8 and 11.6. When I add them together, I get 21.4. And that is, in fact, bigger than 19.3. So that is a triangle. So again, you plug in your two smaller sides for A and B, and you're checking, is it greater than your largest side? Simplify your expression. And if that's a true inequality, then yes, it is a triangle. If it's false, then it's not a triangle. But for your warm-up, they better all be true. So you're just proving it. So try that with your warm-up right now. Okay, on Khan Academy, it'll give you a similar question. Is it a triangle? Again, find your two smaller sides, plug them into the formula, simplify it, and if it's either true or false. In this case, it's false, so it's not a triangle. Okay, now if it asks you for what could the third side be, there's this special range formula. Basically, it's going to give you two numbers and ask you what the third side could be. You subtract them to get the smallest number, and you add them to get the largest number. So what does that look like? Well, here's an example in Khan Academy. I don't know what this side is. It could be, if I subtracted them, it could be 3.2. I know I'd have to draw it a little differently. And if I added them, it could be 8.8. So any number in between there. So this could be 5. This could be 8. I know it's already drawn, so it's obviously going to be some number bigger than 6. But we are doing a theoretical range. They're not always going to give you a triangle. Okay, so tape this in your notes. I'll grade this at the end of class today or at the beginning of our next class because we still need to do this last box. But let's go into our notes, title it 4.1 Intro to Triangles, and we are going to take some notes on paper. There are 3 Khan Academy exercises that you can do already if you need to take a notes break. Just pause the video and do that. So Intro to Triangles, how do we classify triangles by sides? If you don't remember from back in the day, there were 3 ways. Scalene meant all 3 side lengths were different. Isosceles meant 2 or more side lengths were the same lengths. And equilateral was where all sides were equal lengths. Lateral means lengths. So go to your warm-up, and looking at your warm-up, classify it by sides. So for this one, it has 3 different side lengths. So this one is going to be a scalene triangle. Okay, now how do we classify it by angles? There were 3 main ways to classify by angles. If you have a big old angle greater than 90 degrees, then it's an obtuse triangle. If you have a 90-degree angle, it's a right triangle. And if you have all 3 angles less than 90 degrees, it's an acute triangle. And then there was a special type of acute triangle, and that was if all the angles are 60 degrees, we call it an equal angular triangle. It is an acute triangle. It's just a very special name because they're all equal angles. So go back to your warm-up and let me have you classify it by angles. So hopefully by now you've classified it. This example was a right triangle. It's a right scalene triangle. So that's how I could classify this triangle. Now if it wasn't a triangle, like I did this triangle inequality, and I got that it was not a triangle, then you do not classify it because it's not a triangle. So for this example, this one was an obtuse and a scalene triangle. I have this little handout I have in the buckets. If you want to, you can tape it on top. Don't tape it below or it'll run out of space. You can just tape it on top because it's saying the exact same things we already wrote down in words. It just has pictures for it. Remember, these little dashes mean they're equal. If it has a different number of dashes, that means these two sides are not equal, but these two are equal. So just to review those things. Okay, so our notes look like this. We should be a little bit less than halfway through the right page. If you run out of space, write it underneath the warm-up on the left. But what if you don't have all the angles and you still want to classify it by angles? This is the new thing from high school. We call this the converse of the Pythagorean theorem. If you remember the Pythagorean theorem, it is a squared plus b squared equals c squared. And we use the Pythagorean theorem for right triangles. But if it's not a right triangle, if it's an obtuse triangle or an acute triangle, we can still use some version of the Pythagorean theorem. So again, if it's a right triangle, a squared plus b squared equals c squared, and you're plugging in the sides, because again, we don't have the angles. We're assuming we don't have the angles. I know y'all have the angles for your warm-up, but we're assuming we don't. If it's an acute triangle and you plug it in, your two smaller sides compare it to the third side, you would find out that the two smaller sides squared and added together is always bigger than the largest side squared. The way I remember this is if the little alligator is eating the A for acute, then it's going to be an acute triangle. Okay, if it's an obtuse triangle, I think y'all can guess it. It's going to go the other direction. So a squared plus b squared is going to be less than c squared. I kind of connect it and make it a circle. So I think if the alligator is eating the circle, then it's an obtuse triangle. That's just how I remember it. Okay, so for example, again, the first step is you have to figure out, is it a triangle? So here's a little quick example. 3, 5, and 8, when I plug them into the triangle inequality, the formula that's on the left of your notes, I realize that 8 is greater than 8, which is not true. 8 equals 8. So this is not a triangle, so I'm not even going to worry about classifying it. I'm not going to worry about classifying it by sides or by angles. Now here's another example, 4, 5, and 8. Again, is it a triangle first? A plus B, is it greater than C? Again, I plug in my two smaller sides, add them. Is that greater than the largest side? So 9, is it greater than 8? Yes, it is a triangle. So now I can classify it by sides. I'm again given the side lengths, and I know they're all different side lengths, so that is scalene. But I don't have the angles. And I can draw a bunch of versions of this triangle, doesn't mean I'm drawing it accurately. So to prove it, we're going to use the converse. So I'm going to figure out my a squared plus b squared, how does it compare to my c squared? And I'm going to show my work, because proving is showing your work. Again, a and b are your two smaller sides, c is always your largest sides. So show me how you plug it in. And then simplify this left-hand side. I get 16 plus 25 is 41. 8 squared is 81. And I see that they're not equal, so it's not a right triangle, but the right side is bigger. So remember, if the right side is bigger, if c squared is bigger, then it's an obtuse triangle. So let's go to your warm-up and let me have you prove, we already know obviously because you measured the angles, but let me have you prove what type of triangle it is in this little box right here. And again, this whole worksheet will be a grade, so double check with your buddies that you did it correctly, because even though you're working on it together, the one that's taped in your notes will be your grade. Okay, we have finished our notes, so your homework tonight is going to be finishing up the Khan Academy, but right now we are going to work on a worksheet. So please keep your notes out and we'll work on a worksheet. Thanks.